Hi all! In this video we will be going over vectors, how to break vectors into components, and how to add vectors. So remember that a vector has magnitude and direction. So if we want to focus on breaking a vector into its components, so meaning having a vector and expressing its magnitude and direction in a way that allows us to add components. So one way to do this is to break it into our Cartesian coordinate system. So say we have y-axis here, and x-axis here, and we have some vector v that points this way, and we have another vector u which points that way, and we want to be able to express what the vector t, which is the sum of u and v, is as a whole. So the way we have to do this is we have to break v and u into components, add the individual x and y components so that we can end up with t. So if we draw in this as a little triangle, we'll have the y component of v, and then down here we'll have the x component of v, and we will say that this angle right here is theta. So if we remember from trig, sine of theta is equal to the opposite over the hypotenuse, and the opposite to this angle here is vy, so that equals vy over, and the hypotenuse is v. So we can solve for vy as v times sine theta, which is nice because sine goes from -1 to 1, so the biggest this can ever be is v, and for any angle that isn't 90 degrees it will be smaller than v. Likewise, we can look at vx, that's cosine theta equal to adjacent over hypotenuse, and in this case vx is the adjacent, v is the hypotenuse again, so we have vx over v, and our vx equals the cosine theta. So we can write our v vector, so you know it's a vector because it has a little hat over it, as v cosine theta, v sine of theta. This is the x and y components. We can do the same thing with u. So we can have an angle right here, it's alpha. We can have our u of x and our u of y, and using this right here, our u of y will be u sine alpha, and our u of x will be equal to u cosine u cosine of alpha, and we have to add in a negative sign because it's pointing in the opposite direction over here. So this, we said pointing to the right is positive, so pointing to the left has to be negative. So our u is equal to u cosine alpha, negative, and then u sine alpha. Now our t. The x component is going to be just the sum of the two x components. So it's v cosine of theta minus u cosine alpha. T of y going to be v cosine theta plus u sine theta. So this, we can rewrite this as our t vector is equal to v cosine theta minus u cosine alpha, comma v cosine theta plus u sine alpha. So this is our x component, this is our y component. Now what we need to do is figure out what the magnitude of t is and what direction it points in. So if we go back to looking at, say this is t, and we have our t of x, and we have our t of y. This is the hypotenuse, these are the two sides. From trig, t is equal to the square root of t of x squared plus t of y squared. So in our case, it's t equals the square root of v cosine theta minus u cosine alpha squared plus v sine theta plus u sine alpha, all that's squared. So this is the magnitude. The way that physicists typically represent magnitude is by having straight bars on either side of the quantity. Now to figure out what the angle is here, theta, if we have ty and tx, we can use some trig. So the tangent of theta is equal, let's use a different angle. It's wherever you're using theta there. So let's say that this angle is beta. Tangent of beta is equal to opposite over adjacent. And in this case it's ty over tx. So this is going to be tangent beta equals v sine theta plus u sine alpha all over v cosine theta minus u cosine alpha. And then to get the angle, you just do the inverse trig of it. So you do inverse tangent of v sine theta plus u sine alpha all over v cosine theta minus u cosine alpha.